Okay, in this video, what I'd like to do is try to really explain to you the meaning of the confidence interval for the mean. JUMP has a really nice simulator in it that'll really help you understand it. You know, most people, when they think of a confidence interval and they try to say it in words, they say something to the effect of, you know, I am 95% confident that the population mean, you know, whatever you're talking about, lies in between, you know, these two numbers that we just found. You know, that interpretation is common, but it's not actually entirely true. So my goal right now is to try and show you through a simulation, you know, what is this thing? You know, what does the confidence interval for the mean really represent? All right, so I was looking at the SAT from last year. I think it's the class of 2017. And you can see let's talk the math right here. You can see the math. The mean score was a 527 out of 800 with a standard deviation of 100. You know, and SAT scores are, you know, obviously a standardized test, and we know them to be nicely bell-shaped. So the distribution shape of this SAT, the population mean is 527, and I'll put the standard deviation under here of 107. All right, so now what? Well, imagine reaching into this population and grabbing a sample. So I'll reach in there and pull out a sample, and here's my small sample right here. And let's say the sample, n, lowercase n, is 25. So imagine grabbing a sample of 25, you know, random math SAT scores, and then calculating the sample mean, x bar. Now, obviously, I'm not going to do this. We'll ask JUMP to do this for us, to go in there and grab 25 random SAT math scores. And then, you know, once you have those 25 scores, obviously you could average them and get your sample average, which, you know, the central limit theorem says that it should be close to this 527. But, you know, what is that average going to be? Well, I don't know. It might be a little bit higher, it might be a little bit lower. But remember, we found a technique, we discovered a technique this week to calculate a confidence interval, which will give us an interval with a certain probability level or good faith level that we feel comfortable where this population mean would live. All right, so what I'm going to do is show you a simulation of this. So I'm going to go to JUMP, and one of the add-ins I had you put in there was this thing called teaching modules. So if I go to teaching modules, one of the modules is the confidence interval for the mean. So I'm going to select that. And this nice window opens up. And as you can see, there's a section where the population characteristics are given. So I'm going to go in there and input the population characteristics for this particular scenario, which the mean was 527. And the standard deviation was 107. And then the name of the variable, this is the SAT math. All right, so what am I going to do now? Well, look what I have the next menu set up as, where it says demo characteristics. Sample size. It's when you open this menu, it's pre-set up as 25 samples. In other words, when I go back to my distribution of SAT scores, right? So here's my SAT math scores, and that's the population now, don't forget. This is the population of students that took the SAT in 2017. Reach in there and grab a sample of 25 students. What's going to happen there? So what I'm telling JUMP is, hey, you know, you got this distribution made up of these characteristics. Go into this population and grab me randomly a sample of 25. And it says number of samples. In other words, do it once. And then notice I have a confidence level set at 95%. All right, so I'm going to leave that stuff alone. And it says use known population standard deviation. I'm going to check yes there. And animate illustration, I'm going to say yes as well. All right, so now I'm going to ask JUMP to reach into this distribution, which don't forget is this distribution here. Reach in there, randomly grab me 25 pieces of data from there. And then after you have that, construct me a confidence interval using the technique that I showed you in this section. So I'm going to go this run simulation button. It says draw samples. I'm going to push that button once. And notice what it did. It, over here in the sample summary table, it said, all right, I did that, and look at the mean, 501.9. The mean's supposed to be 527, but, this is the mean it got, and the standard deviation is 113 for that. Standard deviation is supposed to be 107. You can see the statistics are relatively close, and it calculated a confidence interval, and here's the confidence interval in green. And did they put it anywhere else? Yeah, here it is. The button's just not opened. If I open the button here, there's the lower and upper confidence limits. So the lower limit is about 460. The upper limit is about 544. And notice that confidence interval, it actually does contain the real population mean of 527. So the mean of the population lands within this first confidence interval. All right, so let's do this several times. So what I'm going to do is I'm going to reset. So I click the reset button. And then the number of samples, I'm going to pick something a little higher than 1. I'm going to tell it to do this 100 times. All right, so when you do something like 100, I don't want it to animate it because it'll take too long, because then you'll see just one confidence, it'll calc another, and that takes some time. So I'm just going to say, no, don't animate it for me. Just show me them all. So, it's a computer. It works really quick. So what's it going to do? It's going to go back here, and here's the first one. So I'll call this N number 1. Then it's going to reach in and grab another sample, call that N2 of 25. And that X bar, whatever that is, and dot, dot, dot. It's going to do this 100 times. So N100, which will still be 25 samples. And what's that X bar? Which, again, I don't know. So it's just going to do this 100 times in a row right now and calculate 100 confidence intervals using these 100 different sample means. All right, so let me go back there and say run that simulation, draw additional samples. And as you can see, as quick as you can blink your eye, it calculates 100 samples and 100 confidence intervals, which is pretty remarkable, right? The only thing now is, notice when you look at the confidence intervals that are here, and every one of these lines represent a confidence interval. Notice there's some, most of them are green, and notice some of them are red. All right, so what's going on there? Well, if you click on any particular green one, you'll see that, I just clicked on one which happens to be the 12th sample, and you can see the lower and upper limits of 517 and 600, and notice that that actually contains the population mean of 527. But notice one of these red ones, for instance. I'll click on one of these red ones. This was the 28th sample, and notice the lower limit was 462, and the upper limit is 546. Oops, maybe I didn't grab that one I wanted there. Hold on. I did not. I clicked on the wrong one. As you can see, it's tough because I'm clicking with a little pen here. I tried to click right on that red one right there, so I finally got it. And here it is. It's the 27th sample. Look at the lower confidence limit. It's about 533. The upper confidence limit, which is 617. Notice that that confidence interval did not contain the 527. All right, so what is that telling us? Well, right here it's letting us know down at the bottom what percent of our confidence intervals actually do contain the population mean. And as you can see, it's saying 92%. So out of these, all these confidence intervals we just calculated, how many of them? Well, 100 of them. There's 100 confidence intervals in there. 92 of them, which will give you 92 out of 100, which is 92%. 92 of them have the, actually do contain the population mean of 527. All right, so now what does that mean? Because, what is the meaning of this 95% confidence interval? Well, theoretically, in the long run, this number down here should really be 95%, because the 95% confidence interval actually means, in the long run, when you just keep, simulating this over and over and calculating all this data, 95% of these confidence intervals should actually contain it. All right, so what we could do? We could just keep drawing more samples. In other words, if I click this button again, it'll grab 100 more samples. And notice right here, it says number of sample means. It did this procedure 200 times. We now have 200 confidence intervals. And you can see here's the next batch of confidence intervals here. And now look at the bottom here where it says percentage of confidence intervals containing the mean, 93.5%. And we could just run this simulation several times. Keep going. Now it's 300 samples, 400 samples. And it just it keeps recalculating the statistics each time. And, here I am at 600. I'm going to go up to 1,000 samples. 800, 900. All right. This is imagining now going into this thing right here and ... Imagine reaching in 1,000 times. So in other words, N1000. Grabbing 1,000 samples, and every one of those 1,000 samples calculating a confidence interval. So check out the results here. 94.4% include the population mean. All right, there's your true meaning of your 95% confidence interval. Look how close we are. I bet by the time we, push this button a few more times, we're going to be right there where we want to be. But here's something pretty interesting as well. Notice the mean of the sample means, which is 526.86. All right, for all intents and purposes, that's 527, which notice is the actual mean. Of course it's the mean. That makes sense. If you're reaching into a population with a known mean of 527 and you grab a bunch of data and find the mean, obviously the mean should be really close to 527. All right, but here's something interesting. Right here, the standard deviation of the sample means, and it's 21.36 about, right? And you're like, wait a second, the standard deviation is 107. What's going on there? All right, well, remember, we're talking about grabbing samples. And, samples, as you know, involve the central limit theorem. And remember, the standard error, this is called the standard error of the mean. Most people just call it SE mean. And that is called, symbolically, it's sigma x bar, which is just sigma over radical n. All right, well, the sigma was 107. We got that. Divided by the square root of, well, the number of samples, as you can see, it tells us sample size 25. Okay, so if I go over here and pop a 25 in there, 107 divided by the square root of 25. All right, so let's see. 107 divided by the square root of 25. 21.4 is that sigma x bar, which is called the standard error for the mean. If I go back to jump, 21.36. You can see we're just about nailing it. Just about on the money there. So this thing right here, standard deviation of the sample means, that is actually the standard error of the mean, which is sigma divided by the square root of n. All right, so what's the true meaning of confidence interval? Go into your population. Start drawing random samples of a certain sample size. As the sample size increases, the distribution of sample mean starts to approach a normal distribution. More importantly, once you get these confidence intervals and calculate these confidence intervals, what goes on with the confidence intervals? What is the meaning, the true meaning of a 95% confidence interval? Well, the true meaning is actually that 95% of these confidence intervals, well, let me say it this way, 95% of those sample means that we grabbed will create a confidence interval that in fact does contain the true population mean. And you can see even with our simulation, we're at 94.4. And, you can sit here and just play around and push this draw additional sample scenario many, many times in a row. And I've done this, and I just pushed the button a bunch of times. And, as you can see, this thing right here now starts hovering right around 95%. And the statistics are kind of right where you would expect them to be. All right, so here's your true meaning. It's not going to stop other people, though, from saying, hey, I'm 95% confident. Like, if you look at this particular confidence interval, I'm 95% confident that the population mean lies within these boundaries. That is the popular way of saying it, although that's not the true meaning of it. All right, I hope this video helped you out in understanding what the meaning of the confidence interval is. If you have any questions, feel free.